Today we're going to learn how to simplify this expression. How do you simplify this expression and deal with all of these pesky negative exponents? Well, if I was to simplify this, the first thing I would do is I would first try to find out what is going on inside these brackets. So what's going on in the first set of brackets and the second set of brackets? If you look at the first set of brackets, you'll realize that actually we just have a product inside these brackets. So we have 3 times x minus 1 times y minus 2. So this is a product with 3 factors. It's just basically a multiplication of 3 components or 3 factors, 3x minus 1 and y minus 2. And this product is all raised to the power of negative 2. So because this is a product that's raised to a power, we can use an exponent law that says that if you have a product, say a product of 2 factors a and b, and then you raise this to some power, say n, then this is equal to having a raised to the power of n and b raised to the power of n. And we can apply this law to this bracket, despite the fact that we have 3 factors here, because this exponent law, it applies irregardless of how many factors you actually have inside the bracket. So if you have 2, it applies. If you have 3, it applies. If you have 20, it applies, etc., etc. So we have 3 factors here. We can directly apply this exponent law. Now let's see what's going on in the second bracket over here. Well, you'll notice that the second bracket over here is also a product, and this product also has 2 factors. Well, I mean, it has 2 factors, which makes it the same as this one, but it's not the same as the previous one because the previous one has 3 factors. So the 2 factors in the second bracket are x squared and y to the power of 7. And this is all raised to the power of negative 1, and so we can use the same exponent law. So let's see how that's going to look like in practice. So the first thing you're going to want to do is you're going to want to write an equal sign, which says that we're going to write an equivalent expression. Then you want to drop down the brackets, and then I'm going to write 3 here, but I'm going to write 3 in its own brackets. So I'm going to write it in a set of brackets. This is the same as 3, except it's enclosed in brackets. Now, why am I doing this? Well, this will become apparent when we get to the next line. So I'm going to write 3, and now I'm going to raise it to the power that is outside of the bracket, as that exponent law allows me to do. So I'm going to raise it to the power of negative 2. And now I'm going to do the same thing for x to the power of negative 1. So I'm going to write x to the power of negative 1 inside its own brackets, and then I'm going to raise that to the power of negative 2, the power that is outside the bracket. And then I'm going to do the same thing for y, so I'm going to write y to the power of negative 2 inside its own brackets, and now I'm going to raise it to the power of negative 2, and now I'm just going to close that bracket. Moving on to the second part of the expression, the second bracket, well, I'm just going to do the same thing. I'm just going to take this x squared, and I'm going to raise it to the power of negative 1. And now I'm going to take this y to the power of 7 and raise it to the power of negative 1 and close the bracket. Right, so why would we want to do this? Doesn't this expression look quite a bit uglier than what we started off with? Well, actually, no. This is significantly easier to work with because now we can apply another exponent law. So we can apply an exponent law that basically says that if you have a number that is raised to some power, so if we have some number a that is raised to some power m, and then you raise this to yet another power n, then this is equal to a to the power of m times n. And we can apply this law directly to every single factor in each of these brackets. So we can apply this to this 3, it's bracketed and it's raised to the power of negative 2. We can apply this to the x to the negative 1, it's raised to the power of negative 2. So x in this example is like a, m is like negative 1, and 2 is like n, and then we can just multiply these together. And so we can do this for essentially every one of these 5 factors that we have here. So let's do that. So again, equals sign, because we're going to write an equivalent expression, this bracket. And now we're going to write 3. And now, well, I mean, what are we going to multiply by this negative 2? We have 3, but 3 doesn't have a power. Well, 3 actually does have a power. 3 implicitly has the power 1. Every time you just write a number without a power, it implicitly has a power 1. So this is 3 to the power of 1 times this negative 2. And then you move on to the next factor. You have x to the power of negative 1 times this negative 2, y to the power of negative 2 times this negative 2, and now close the bracket, move to the next bracket, x to the power of 2 times this negative 1, and now you have y to the power of 7 times negative 1, and don't forget to close your bracket. And now for the very next line, all I have to do is I just have to perform the multiplication inside every one of these exponents. And so that's what I'm going to do here. I'm going to have 3, whoops, let me just get the color right, 3 to the power of 1 times negative 2. Well, 1 times any number is just going to be that second number. So this is to the power of negative 2. And now we're going to multiply this by x to the power of negative 1 times negative 2. Well, a negative times a negative is going to give you a positive, and then 1 times 2 is just 2, so we're going to get a positive 2, or just 2. And now you're going to have y. Y is to the power of negative 2 times negative 2. Negative times a negative gives us a positive again, and 2 times 2 is 4, so y to the power of 4. And just close the bracket. Move on to the rest of the expression. X to the power of 2 times negative 1 is just equal to x to the negative 2. And now you have y to the power of 7 times negative 1, so y to the power of negative 7, and close the bracket. Now what does this expression give us? This expression is significantly easier to work with than the expression we started off with, because this expression that we have now arrived at, this expression does not have these pesky exponents on these brackets. And in fact, we can actually just get rid of these brackets using something called the associative property of multiplication. The associative property of multiplication. And what the associative property of multiplication basically says is, if you're going to multiply a bunch of numbers together, it doesn't matter which numbers you multiply first and then multiply the rest. So basically, if you want to multiply like A, B, and C, some numbers A, B, and C, it doesn't matter whether you multiply A and B first and then multiply the result by C, or whether you multiply A by the result of multiplication of B and C, or whether you just leave the order ambiguous just by writing A, B, and C, and let basically the solver decide which number they're going to multiply by which number first. All of these are equivalent, and this is called the associative property of multiplication. And it's very clear that this can apply directly to this whole expression here, because we have a product in a bracket multiplied by a product in a bracket, and two brackets facing each other like this always mean that there will be a multiplication. So we got multiplication of this factor times multiplication of this factor times multiplication of this factor. Then we're faced with a multiplication, and we have a multiplication of this factor and a multiplication of this factor. So we can essentially just break these brackets and write the expression without brackets at all. So by the associative property of multiplication, you can just write directly 3 to the negative 2 times x squared times y to the power of 4 times x to the negative 2 times y to the power of negative 7. Okay, so now we can use yet another property of multiplication. This one is called the commutative property of multiplication. And the commutative property of multiplication basically says that if you have terms that are factors that are multiplied together, it doesn't matter which order you write these factors in. So let's say you have two factors multiplied together in a product, a times b. You can write it as a times b, but you can also write it as b times a. And of course, this will extend to however many factors you have here, right? You can just write them in whatever order you want. Here we have 5 factors, 3 to the power of negative 2, x to the power of 2, y to the power of 4, x to the power of negative 2, and y to the power of negative 7. We can rearrange these however we want according to the commutative property of multiplication. So what would be a logical way in which we would want to rearrange this? Well, the most logical way to rearrange this is to have those factors that have the same base beside each other. So we want these x's beside each other, and we want these y's beside each other. And it's typical to usually arrange it in such a way so that the bases are in alphabetical order. So you start with numbers, and then you move to the bases in alphabetical order. So you're going to want to write 3 to the power of negative 2, and then you move on to the x's, because alphabetically x's come before y's. So you're going to have x to the power of 2. Then you're going to have this x to the power of negative 2, which you're going to put beside it. And then you put the y terms. So you're going to have y to the power of 4, and then y to the power of negative 7. Right. And so now what does this give us? What does rearranging this give us? Well, now you can apply yet another exponent law. In this case, you can apply the law that says that if you have some number raised to a power multiplied by that same number raised to a power, where m and n could be the same power or they could be different powers. Like here we have x and x, so these bases are the same. It's like a and a is the same, but they're raised to a different power. That's fine. They could be the same power or they could be different powers. Then this is equal to a to the power of m plus n. And we can apply this exponent law. We can apply this exponent law directly to x's and y's in this expression. So we can write 3 to the negative 2, and now let's apply this rule to these x's. So we have x to the 2 plus negative 2. And then to the y's, where we're going to get y to the 4th plus negative 7. Right. So now, on the very next line, all I'm going to do is I'm going to just do the basic arithmetic we have here in the exponents. So we're going to have 3 to the negative 2, and then we're going to have x, where we have 2 plus negative 2. 2 plus negative 2 is just equal to 0. And then y to the power of 4 plus negative 7. 4 plus negative 7 is just equal to negative 3. And now we can see that we have an x to the power of 0 here. We have an x to the power of 0 here. So we can apply another exponent law to evaluate this x to the 0. And this exponent law basically says that if you have any number to the power of 0, this is equal to 1. It's just a rule. It's just an exponent law that you just have to remember. So here we have x to the exponent 0, so we can replace this with 1. So let's go ahead and do that. So here we're going to have 3 to the power of negative 2, and then times this 1 times y to the negative 3, because of the fact that x to the 0 is equal to 1. Now, any number multiplied by 1 is just itself, so if you multiply two numbers by 1, it's going to be equal to itself. So if we have 3 to the negative 2 times 1 times y to the negative 3, then we can just drop this 1. We can literally just get rid of it. So that basically means that what we're left with is 3 to the negative 2 times y to the negative 3. Now, how are we going to deal with these annoying, these pesky negative exponents? Well, in order to deal with these pesky negative exponents, you have to use yet another exponent law. This exponent law basically says that if you take some number and you raise it to a negative power, this is equal to 1 over that number raised to the positive power. So we can apply this to get rid of these negative exponents. And so we can apply it directly to the first factor, and then we can apply it to the second factor. So what we're going to end up with is 1 over 3 to the power of 2 times 1 over y to the power of 3. Now we're almost done here, but you just have to realize that 3 squared is a number that we can actually calculate. So 3 squared is just equal to 3 times 3, and that's equal to 9. So we can just go ahead and replace this 3 squared with a 9. So all we're going to get is 1 over 9 times y, or rather 1 over y cubed, and that is almost our final answer, except the final thing we have to do is we have to combine this into one fraction, and in order to do this, all you have to do is multiply the numerators and multiply the denominators. So the numerator is going to be 1 over the denominator, 9 times y cubed, 9y cubed. And that's your final answer.